All right, welcome back. I hope you're having an amazing time so far. Our next speaker is Vikram Chatterji. He is the co-founder and CEO at Galileo Technologies. Please join me in welcoming Vikram to our virtual stage.
Thank you so much, Patrika. Let me quickly share my screen. Great. So in this talk, I'm going to focus on why for machine learning to be truly effective in business critical applications, it is really important for us to focus on the data flowing through ML workflows. And I'm going to talk about that through the arc of time. So just to take a step back really quick, for the last 2 decades, we've all known that software applications have been built on a tremendous scale, especially with the advent of the cloud. And you see software applications everywhere across mobile devices, web devices. However, over the last 5 years, a very interesting thing has been happening where ML applications, machine learning applications are increasingly pervasive. And if you think about it, it's absolutely crazy to see how proliferated they are in our day-to-day lives, all the way from simple text autocomplete in your inboxes to cancer detection to even affecting social and purchase decisions with personalization across all of your media apps, from Google searches to Netflix. It's everywhere. So the question has shifted quite a lot because of the proliferation of ML applications, which are in its early innings, really. It's just getting started. We're just beginning to figure out where and how we can use machine learning in business critical needs for really high ROI, much, much higher than just rule-based systems. But because these applications are for really high stakes decisions, the question is shifting. The shift essentially is from a question which we used to hear a lot about 5 years ago, which is, what are some useful applications of machine learning? And we saw this across different industries. We saw this in the financial services world where people realized that, wait, you can use ML for anti-money laundering. And it works really well. And it saves you millions and millions of dollars per year. You can use machine learning in healthcare with electronic medical records. And it works really well. It works better than maybe sometimes what radiologists could do on a day-to-day basis. And so we're realizing all of that. We've tried that out in industry. We've seen some useful applications of machine learning. And now the big questions become, great, now we know where we can apply this. The question is, how do we build high quality machine learning applications? How can I be extra sure that if I'm making a prediction for someone's health or someone's finances, I am making that prediction in a really, really good way? The predictions have to be high quality. Now, when you think about a machine learning application, there are just three big parts to it, really. There is the model or the algorithm itself. There's the data, which is the lifeblood of the entire ML model. And then there's the code that binds it all together and helps you deploy the machine learning model. That being said, if you look at how much focus there is across these three pieces today and over the last maybe 5 years as well, it makes sense why, but it's imbalanced towards the model. And it makes sense why, because the entire research industry was focused on building better algorithms. Google, Facebook, Amazon, all of these big companies were pumping in a lot of resources to make their algorithms better because it was new. It was really important to have good algorithms. However, because of that, that has resulted in this really imbalanced view of the world where the primary theory today has been around, let's throw more data at a machine learning application and best results are going to show up that way. The model is the hero, not the data today. And this has led to some really interesting and not so good outcomes where, when you look at actual ML practitioners today, again, everyone wants to do the model work, not the data work. And this is a paper from some of my past ex-colleagues at Google, where we figured this out ourselves, where we were building machine learning applications for industry. And we noticed that as soon as we shifted our focus towards data and data quality, great outcomes were coming through. But it was extremely messy to do that because data is messy. And it's very hard to work with data and making sure that high quality data is constantly flowing through the lifeblood, through the entire system of the machine learning application. So the focus mostly is on the model today. And this is a constant across the industry. The reality, however, is that if you look at models today, there are a lot of really well-trained models. These really massive models, which are increasingly commoditized. especially when you look at text data and NLP, or even for images. You can look at Hugging Face as a classic example of this, where you have transformer technology, where you can literally pick up an ML model from the shelf and start using it within minutes. This was impossible a couple of years ago, and now it is possible, because of which the barrier to entry from a model perspective is really low. So it's no more the Google research and Facebook research that can do this. Anybody can use amazing models to build their ML applications. However, when you look at the data side of things, two problems persist. Number one, data is extremely hard to come by. So if when you're getting started with a machine learning application, where do you get great data in the first place? So creating that data is really, really hard, and because of which the outcomes of the ML model can be really poor. Even if it is available in troves, let's say you have a social media app that's gone viral, you have a ton of data, it's really important to fuel your machine learning model with really high quality data. And high quality data is a really broad topic. It can be in bunch of different things, but essentially it means that making sure that the predictions from the model are really good based on the data that you've trained it with, and constantly tweaking that. And that's something which is not of high priority right now. It's shifting, but it's not of high priority right now. Even if you look at canonical data sets, the massive data sets which have been, the massive models which have been trained with, let's say, Wikipedia data and the entire dictionary, even they have a really long tail of low quality data. And this leads to data errors and biases. And this is really bad because it leads to model prediction errors and biases in very critical applications across healthcare and financial services. And this makes sense why this is happening, because all of these big models are based on real data. And real data, if you think about it, today the world is biased in certain ways. And essentially the model is also going to bias in the exact same ways because of the data that it was built with. However, it doesn't have to always be this way. There is a balanced approach that we can work towards. And the balanced approach involves continuously inspecting, monitoring, and fixing your data sets across the entire ML workflow. And the key word here is continuously. Today, some ML practitioners are beginning to look at their data more, but it's a very stop and go fashion. So you look at your data during the training phase and you let it be. The model's in production, you completely forget about it. I've met my KPIs. But that's not the way it should be. It's a continuous process. You should train your model. You should check for the data set when it's in production, and that should influence your decision for what the data quality should be like for the next iteration of training your model. And that's extremely important for having really good predictions for your model, which is, again, very important to influence the outcomes of your model, which could be could be a life and death matter for some people in healthcare. It could be a massive financial decision for someone in financial services. In driverless cars, it could, again, be a life and death question. So it's extremely important to have a continuous inspection and monitoring of your data sets across the entire workflow. And this is something which I call ML data set engineering. And I think of this as something which ML engineers, data scientists, the ML practitioner community are increasingly going closer and closer towards, but not fast enough. And I feel like ML dataset engineering should be something which people think about constantly. How are you continuously engineering your data set so that it's of the best quality that it possibly can be? Today, I do notice that this is a blind spot for a lot of ML practitioners, mostly because of the lack of tooling or the lack of knowledge about how to do this. It is increasingly becoming more top of mind, but I can't emphasize how much this needs to be at the fore and of how we build ML applications today. And we definitely need to be more intentional, therefore, about continuous ML data quality, much more than we have before, just given the criticality of ML applications and the exponential curve that we're noticing today in the building of new ML applications. So just to summarize, this is exactly why I feel like being data first is the future of AI. And to truly build useful, unbiased, and really high quality applications with machine learning, the best machine learning teams are going to shift from this mindset of being model first and only tuning the model towards intentional data set engineering in the future. Thank you so much, and happy to take questions as well.
Amazing, Vikram. Thank you so much for sharing with us. That was awesome. And I know this virtual audience is giving you a huge virtual round of applause. We really appreciate your insight today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.